Hi, welcome to Senior Design 1. Today we're going to be talking about the electrochromic thin solid films for smart window application. This is Team 10 and the members are Naraz Lakmouche, Leonardo Monzon, Carlos Hakin, Romain Price, and Tensley. So we're going to be talking about the overview. We're going to be going over the project description, the markability, problem statement and objectives, the intended users and the intended uses, the background, the intellectual property, the ethical consideration, final concept, and the conclusion. So for the project description, this project is going to be improving the material of the composition of the ET solid films and devices through measurements, research, analysis. And we're gonna be talking about what an EC film is, and it's the technology behind the dynamically tinted windows, and it is used to control the flow of light. The chemical layers, as you can see here, are sitting between an anode and a cathode exterior that allows a chemical reaction like a rixoid, as you can see right here, to generate a current of electricity. Another outcome of this chemical reaction is that the dyed layers change orientation and the film becomes completely clear, as you can see right here. So for the markability, the EC film can be applied on any window. Imagine yourself, you're on your early morning commute, and then you turn a corner and the sun rising over the horizon immediately glares into your eyes and you can't even see the road. You take one hand off the steering wheel to block the sun and it barely even helps. So you're approaching the stoplight, but you can't tell if it is a green or red light. So if you had one of our film applied to your window, it would never happen. This film can be used for the energy consumption loss in buildings. It can be used instead of the dirty, dusty curtains for better air quality inside the house, as well as an interior with clean lines and an elegant design. And for the problem statement and objectives, as you can tell, our goal is to solve the negative effects of the sunlight passing through windows, and it is an imperative that our film will be safe, reliable, effective, beneficial to humanity, and be a product that the people will actually use and want.
Hello guys, how are you doing today? My name is Leonardo Monzon, and I'll be talking about the intent to use and intended users. First, for the intended users, in these reaches we're aiming to create a product that is based for anywhere and that you can use anywhere and anyone can use it. What do we mean like this? Now we're trying to create our product so that way it can be used, for example, for hotels, hospital, cars, houses, bank buildings, offices, and much more. What do I mean by this? When you're in the office, sometimes you're busy, sometimes you're just working there and you're close to the window, and then when it's early in the morning or when it gets in the afternoon, you get the sun reflected to you through the window, and then it bothers you. You get into your vision, you get into your eyes, and this could cause some problems for you, or even concentrations, or it could give you headaches, for example. And all of those, that's what we're trying to avoid. That's what we're trying to help you when we create this type of films for the windows. Also, when we say about the cars, sometimes you're driving, sometimes you're going on the highway, it's really early in the morning, and you get this reflected sunlight into your eyes. This can also cause an accident. It can give you headaches again, and it could make your day even worse. So that's what we're trying to work. That's why when we say we're aiming to create that product that you can use anywhere, anytime, and that anyone can use it, from little kids, because when you create these products and you want to use it into your house, you're also protecting your little kids and you're also protecting your loved ones at home. Now, when we're talking about the intended use, when we talk about the intended use, we have two different ones at the moment, which is the intended outer glass windows, and we also have the intended inner glass window. When we talk about the outer glass window, we're trying to create this for the overheating and also the overcooling for any building and privacy. What do we mean like this? We're trying to create this film into the houses in the outside. Now, when we do the inner glass, we're trying to do so for the inside. What do we mean like this? We're getting into like the taxis, for example, the cars, so that way it could be very safe for the driver, and also it could be safe for germ and also any harms that can cause instead of pulling up and down the windows. In this picture right here, we can see how there's different type of tints. For example, blackout, and also 5%, 20%, 35%, 50%, and 70%. In our films, you're gonna have all of this in once. What do we mean like this? That you own sometimes right now, if you have 70%, maybe in the afternoon, close to like the night, you want to have a 70% because you want to have a vision to the outside. But maybe when it's in the afternoon, maybe like 1 p.m. or even at noon, you want to have something like a 5% so that way the sun doesn't really bother you. So that's what we're trying to avoid over here, and that's what we're trying to use over here. Thank you very much for listening to me.
Hi, I'm part of Group 10. My name is Carlos Hacking. I'm majoring in electrical engineering. Today I'm going to talk about some background information. Background is an important section that will provide us with many details of technologies surrounding our product, as well as other approaches that have been made in solving our same problem statement. Doing research into our topic gives us insight into history as well as insight into the possibilities of claiming a patent. Therefore, learning about our competitors not only gives us a better understanding of the market, but it also allows us to learn from mistakes and add some improvements to our own design. Here are two competitors. As you can see, Priwatt Film and Sage Glass. Priwatt uses a PDLC technology, and also is near instantaneous tint transitions, which is it occurs really fast. However, it needs for constant power. It needs constant power supply. That means that it requires a lot of energy. Therefore, we came to the conclusion that our project will be better. We have a lower voltage use. There's no need for constant power supply. For sure, a better choice of in energy consumption. So we use a lot less energy than their technology. And then we have Sage Glass, which is an easy technology, same as ours. But this is a glass product. We more focused on film. Therefore, a glass it will be harder to replace in an existing building. However, ours, we can apply it to everything basically, in a very low cost. We have ours better because of that. We have a low cost for installation, and installation requires time, so companies don't have to wait long to have this product. We can just go in 1-2 days install it for them. Compared to glass, you have to replace all the glasses in very long time. We also recommend installations, like a professional installation for ours, but you can do it yourself. Is something that we can provide to the customers, and they can figure out with our guide. We also analyzed the Electra 10. It's just like Priwatt. It's also a PDLC technology, and they made a distinct point about hiding the wires, the wires through seamless hardware, and they try to make it look very nice and in different colors, so you have a lot of options when it comes to window replacements. I thought that was a great idea because looks attract people and customers, so you want your product to look good. So we will take this into consideration on designing when designing our own window film.
Hello, my name is Ramin Price, and today I'll be presenting the topic intellectual property and also ethical consideration. As we know, patents are crucial in order to protect an inventor right of ownership from those who would choose to impose on their work and pass it on as if it's their own, by ensuring that there are legal ramifications for such action. In the process of our research on the electrochromic film, we found 3 patents which are closely related to ours. The first is an electrochromic window, which this patent generally related to windows and have a variable transmitting light filter, which generally this pattern is to be used on architectural window, residential windows, and sunroof of cars. We do not infringe on this pattern since the pattern is for the window itself, and our device is a film which is applied to the surface of the glass. For the second pattern is an electrochromatic device which enables the entire surface to darken within a short period of time, and this is intended to be used on any automotive glass and also within the construction industry. We do not infringe on this pattern since ours is a film which is applied either to the outside or the inside of a glass, and this pattern is for 2 layers applied in between. And also the chemical composition of this pattern would be different from ours. For the third pattern, which is an electrochromic device which contains a distributed bar rectifier with regulator which configures to sensitivity to reflect the UV radiation. Our pattern is not focusing on reflecting the UV radiation from a light rather than darkening the surface of the glass. Now to move on to the ethical consideration. For ethical consideration, we noticed within our survey, most people did not know what their state visible light transmission percentage regulatory laws were. So in order to alleviate that problem, we decided on using either their zip code or from their phone, or if you use a mobile device with the location turned on, we could pull that information and use it to notify the customer of what their legal visible light transmission percentage is for their state, therefore allowing the customer to enjoy our product without worry of being pulled over by the police for not being in compliance. Thank you.
Our team came up with several great options for the final concept. Option 1 is a battery-powered source with a 1-year warranty and a dimmer switch to manually control the level of tint on the windows. Option 2 is a plug-in source with a 2-year warranty and sun sensors to automatically control the level of tint on the windows based on the sunshine. Option 3 is a direct wire power source with a 5-year warranty, the sun sensors, but also with a remote controlled dimmer switch to override the sun sensors when you want to manually control the level of tint. Option 4 is a direct wire power source with a 10-year warranty, a dimmer switch, and sun sensors. But the option that we ultimately went with was the one with a direct wire power source, 5-year warranty, and 3 inputs, a dimmer switch, sun sensors, and the optional addition of an app-controlled dimmer technology. The dimmer switch and the sun sensors will be part of the base product. However, we decided that we wanted to offer the app-controlled dimmer switch, shown here in the dashed line. We wanted it to be optional because we found through the survey that those who are interested in it are actually willing to pay additional for it. Electrochromic technologies are technologies with chemical layers sitting between an anode and a cathode. When a voltage is applied, their properties are able to change. This technology is great for the smart tint applications, and smart tints will have a great impact on the future as we know it, to automatically control the level of sun glare, to automatically decrease the energy consumption in buildings, and to ultimately provide a very clean and aesthetically pleasing view, uninhibited by blinds or curtains. Our technology has features that will be very competitive in today's market. There are numerous other applications of electrochromic technologies, not just the smart tint film. We believe that through our research, measurement, and analysis of electrochromic devices will lead to results that will have substantial impacts on the future of current applications, future applications, and other future research of electrochromic devices and technologies. To review, we have discussed several things throughout this presentation: project description, the marketability, problem statement and objectives, the intended users and uses for our product, the background and intellectual property, the ethical considerations, and we have concluded with what our electrochromic device is, what it will be, and how our research will impact the future. Thank you to Los Alamos Labs for sponsoring our research on electrochromic technologies, and thank you for your time.